Well, hello again, Math 126 fans. Going to do a question. Somebody's asking me about one of the last questions on this exam. I'm not going to go through as much of it in detail just because of time, but we're going to scan through, this time a true scan. All right, we have find the equation of a line. Hopefully you have a plan. There's a projection. Hopefully that formula is on our note sheet. We have finding tangent line. That should be a quick question. Finding the curvature. That's a straight computation. Partial derivatives, how do we do that? Find the 2 points of intersection of the surface with the line to the origin and in the direction of this. Of the surface with the line to the origin. So it's a lot to read through, but the question mentions a line. So you would give the equation of the line that they describe. They tell you the direction. So it's 0t 1, 1. Through the origin. Oh, they told us everything. Now we're going to plug that in, get the intersection, and then probably do something with it. Tangent plane, all right? Find the absolute max and min over a given region. So we're going to go one by one across the boundary. Hopefully you have a plan of attack for those ones. Let S be the solid beneath this, and above z equals 0 and over the rectangle. So they give me this region. That rectangle looks a lot like a square. Find the value of m greater than 1. Oh, so that you have this line. The m greater than 1 helps because I don't know exactly what the line is, but I think it looks like this. So anytime it says something like find when you cut the volume in half, I would find the entire volume first, meaning since it's talking about this, I would start by computing this. It will give you a number, and then we're trying to find out when something is a half that number. You've seen that a few times in 125 and in 126. The challenge here was to figure out what region. You could either work with this region, which has 3 sides, or this region that has 4. I'd rather work with the one with 3 sides. That's simpler. So I would have used this region. I probably would have used y, because y goes from 0 to 1. And then based off of y, x goes from 0 out to y over m. So I would set it up as 0 to 1, 0 to y over m, 12xy squared, dx dy equals half of this, compute, solve. So that was a little bit to think about, but anyways, reverse the setup. So draw the region. This is all about drawing the region. I'd love to do that, but I'm trying to not do every single problem. Taylor polynomial. All right. Find the pattern. Plug this into the sine cube pattern. Divide out an 8 and sub this into the geometric series pattern. Blah, blah, blah. Okay, this one. The question that student is asking is about this one. I think it's an error-bound question, so let me just compute a derivative to get us there. 2x over 2 times the square root of 3 plus x squared. Cancel, cancel. Ooh, boy. Second derivative. Denominator times derivative of the numerator minus numerator times derivative of the denominator all over the denominator squared. I think that's what we have to do. Boo. I'm trying to avoid it. All right. It must be all right. We just got to work a little bit. So this is going to be 1 minus numerator. Derivative of the denominator is 2x over 2 square root of 3 plus x squared over the derivative of the denominator squared, which is 3 plus x squared. That looks terrible. But part of the reason it looks terrible is because I have a fraction inside of a fraction. So I'm going to multiply top and bottom by 3 plus x squared. And it does indeed simplify, because that's going to be a 1. And the other one is 3 plus x squared. So, okay, so I'm getting the second derivative. I know I'm not writing it in the correct spaces, but I'm trying to get, the person was asking about part C, and I'm trying to go quickly, if you can't tell. I have a real hard time going quickly because I want to explain everything, but I know students say I talk too long, and they're absolutely right. Okay, 3 plus x squared to the 3 halves. Whew! That would have been a challenge, but you would have had to do it. You had to buckle up. All right, so now we're trying to give an upper bound. We're trying to use Taylor's inequality, and so we have g double prime is this. And we're going to have to think about the biggest this can be on the interval in question. Now, one thing that people often ask about is what's the interval in question if they don't give it? Well, in this problem, we were based at 1. So in your mind, you could be thinking based at 1. That's B. And then we are plugging in. What did we have to plug in? In order to make this 3.25 in part B, what did we have to plug in here? I think it's a half. Yes. So we were using this at a half. X equals a half. So we were based at 1. This is how far away from 1 we got. So whatever you do on this next part, you need to use an interval that contains both of those. In class, I tend to use symmetric intervals, which means I would use this if I was being completely symmetric. But technically, because of the way the question's asked, you only need to go to 1 because it needs to include where you're based and it needs to include where the approximation is. I would accept both of those. It is going to change the number slightly. Okay, so whatever we're going to do, we're going to find this upper bound. And then when we're done, we're going to say the difference between the function and the first Taylor polynomial is less than or equal to this m over 2 factorial or 2 x minus 1 to the 2. And then ultimately, we're going to plug in a half here. So the main thing you have to do in this problem is find something, anything, that you are certain and can show is bigger than this. Well, it's going to be biggest when the denominator is smallest. The denominator is smallest when I put in a half. So that's all I would do. If I was doing this question, I'd put in a half, plug that number here, put in a half here, and be done. I suspect there must be something going on in the solutions that's causing people to ask questions, because maybe the person who wrote the solutions was trying to be slick. And so let's put in a half. I think that ends up being 3.25 to the 3 halves. So again, we would completely accept the following answer. And if you plug in a half, I think you get a half squared. This is acceptable. Stop, stop, stop. Full 100%. So that's it. If I was a student, I'd want to compute the decimal too, just to see that I'm getting something reasonable. But stops, I shouldn't use an exclamation point. Just use it for something else. Stop there. I suspect in the solution, they were like, oh, that's kind of a mess. And maybe for the solution archive, they wanted to give something that was bigger than that. So I think they probably made the denominator 3. So the 3 halves. What a weird thing to do. But technically that does make the denominator smaller, and so it does give you something bigger. And then they probably said that, well, that's the same as 1 over the square root of 3, maybe? And that's smaller than 1. So you could use a 1 here. You could even use 1,000 here. We do want to see the second derivative, but there's no reason to do that. Just plug in the 3.25 and you're good. I hope that answers that.